Open up to those extra examples after example 8. This is the start of day 3. We got, I believe, 4 examples, an extended one, and another problem just to try to see what you know about some things. Well, the first thing we're going to look at is use synthetic division to find the simplified exact zeros of each of the following. Use completing the square or the quadratic formula if necessary. Okay, and I know as soon as I said the completing the square, all of a sudden little fingers crossed. It was like the devil coming after you. It's like, stay away from me. Make sure that we're getting better at this as we go through these. Don't shy away from them. Try them. They're not that scary. They could be that scary, but let's try to see what we can do about them as we go. And if you get an opportunity to ask questions while we're completing the square, that's all the better for everybody. But remember, this is section 2.4, day 3. And again, those assignments up on 2.4, I have their solutions, answers may be posted on a different day, meaning it's in a different assignment because we just threw everything out about what we had planned and did it a different way. So here, the first thing we've got going when I write these down, I've got to pay attention to what's happening with this function. It's 3, 2, 1, 0, so I've got it in the right order. So when I set it up to do this, I'm actually looking at this and they tell me that use 1/2, to find my value. So that's the first one I'm going to do. I'm going to put in 1/2. And just to practice to make sure we're better at this, I want you guys to kind of run through it because you're going to drop the 2 down. This original. Okay, we're going to drop the 2 down. Okay, we're going to multiply by 1/2, and then we're going to combine the terms together, and we're going to drop it down and keep going. So will you guys do this first line and get that done? Freezing? You freezing? Okay, all right, you got your shirt over your hands and your covered hand on your nose. I was a little worried about you. Okay, you're all right? Okay. So I got 1/2 of 2, which is 1, and I add those, I get 2. Another 1/2 of 2, and I get 1, and I get negative 40. Half of negative 40 is negative 20, and I'll get a 0, okay? Now, when I'm looking at these, the idea of this is to, the next step is, to look at it and go, what numbers will go into 2x squared. Remember, this is 2x squared plus 2x minus 40. And I'm thinking about that and, thinking about numbers. I believe there's a 5 that goes in there. If I just step back and wonder, 5 and 8 will go in there really well. At this time, if I can factor it, I don't have to do synthetic again. They say use synthetic division to find the simplified exact zeros. So I know 5's in there, and that's what I'm thinking when I look at that. So I'm popping in a 5. It's negative 5 because it's x plus 5. So I do the same thing because the directions said use synthetic division. So I'm going off on my races, and I got negative 10. I got negative 8, positive 40, and I'm done. Okay, so now I'm looking at my factors as I'm talking about them. I got that 1/2. I got x plus 5, and remember I had that 2x plus 8 or minus 8 on the side as we go through, and she's not here yet. Yeah. Okay. All right. Cool. So as we're looking at this, I'm going to make an adjustment with my function. If I can move this around. My adjustment's going to come out of this function, right? That part of the factor there, because I'm going to add to that, because that's 2x minus 8, which is just 4. So if I can rewrite this and borrow from here that 2 times x minus 4, I'm going to take this 2, take it over there, so I don't have that fraction in my factors anymore. Okay. So what I'm going to do is just rewrite this way. And that 2 came from that other one, so I have everything nice and pretty as my factors are concerned. And now I can talk about my zeros as 1/2, negative 5, and 4. That 1/2 I was given initially, the negative 5, and then 4 were the ones I found afterwards. You guys have the setup of this next one. every time you do these, please make sure you're in descending order. Okay? Every time you do a setup of synthetic, make sure you're in descending order when you set it up. So descending powers of x. 4, 3, 2, 1. Okay, so I'm okay, so you can just pop it in. Go ahead and do the first two. You got 3 and -3, pop them in, and we'll talk about the completing the square step together. I was just going to pick on you a little bit, but I don't want it on record. No, no, it's just I was like, do you need people to like sponsor you to be a citizen? Because I'm sure every one of us would say no. Okay, all right. I just thought I'd ask. I mean, offer up everybody to say no, go back to Canada. No, I'm just kidding. How sad is that? Okay, so we got -3 put in, and you got 3 put in. I think I put them in same order. So when I put this in, I got -3 going on. 1 drops down, and I've got that result. Keep in mind, this is x cubed right now as a factor. And I put 3 in. I pop that down, and now I'm in the x squared as a factor. So I got x squared plus 3x minus 7. Okay, so if I'm looking at my things that make this function so far, I'm sitting right here. Are you doing okay with your findings? Now, I am just going to work with this right now. So I'm just looking for zeros, okay? I'm looking for breaking it down. And so I know I got 2 zeros, the -3 and 3, they gave those to me. I'm going to complete the square on this. You could do quadratic formula on it, but I have an opportunity to once again show you completing the square steps. So I'd like to do that. So I've got this function here, x squared plus 3x minus 7, that equals 0. Okay. The purpose of completing the square, first thing, the x squared term must have a leading coefficient of 1. Okay. This actually happens to have a leading coefficient of 1. So now I'm just worried about taking half of 3, and I'm going to leave it as a fraction. Half of 3 is 3 halves. So I've got 3x and half of 3 3/2 squared, which is 9/4. Okay. Now, in the process, I'm putting that 7 over there by adding 7 to both sides. But since I introduced a value, my 9/4 value, that wasn't there initially, I want to make sure you recognize I'm going to add it to the other side. Are you okay with what I've done so far? We're okay? Now, remember, I'm finding a 0. That's why I set it equal to 0. And I now have a perfect square on the left, so it's x plus 3/2, quantity squared. And 7 I'm going to make in terms of fourth. So now I'm going to take the square root of both sides and combine like terms, but I got 37 over 2. I'm going to stop right there and make sure people catch up to where I'm thinking. Are you doing okay with what I did? I combined the 28/4 and the 9/4. I took the square root of both sides, and in doing so, the square root of 4 in the denominator is 2, so I just yanked that out from underneath the square root. I can't do that with the 37, so that's why I did what I did, is leaving it underneath, but it's plus or minus because be positive or negative would work, okay? Now, I'm just going to get that across, so I got x is equal to negative, so I'm just going to put a fraction bar in there. Or I could even say it's -3 plus or minus the square root of 37. all over 2. Now those are the other part of my zeros, so I could look at it as a multiplying through there, but I'm talking about zeros, so I got my zeros, and I'm all happy from that. Are we doing okay with finding zeros? Yes, no, maybe. Makes sense, my completing the square math steps. Now, please make sure you seek it out. We have completed the square in Chapter P, Chapter 1, and Chapter 2, and I guarantee we will be doing it in Chapter 8, in second semester, Chapter 3, and second half of Chapter 2. So it's one of those skills that we keep coming back to. It's not just one day. Like when you probably did it in Algebra 2, you probably spent maybe a week on it. So just make sure you recognize as we're going through, we're doing an awful lot, so you are more comfortable with doing it, okay? Let's go on to that next one. Now, here's the thing about square roots, and you guys probably picked up on this in Algebra 2. Did you know for polynomials, when we have integer leading coefficients, we have pairs of square roots? Were you aware of that? That they happen in pairs as far as factors are concerned? Okay, so when we're doing this, if I have the square root of 5, I also have the negative square root of 5, because if this is an integer, the only thing that can happen to help it not be some sort of like irrational number on the leading coefficient is I have to multiply by the another square root of 5 to bring it to a real number that's rational. Okay, so if I'm working with polynomials with integer coefficients, they happen in pairs. So let's talk about this. I'm going to pop this in, but again, pay attention to decreasing order. And in this one, everything reversed. So I went on this 1, -1. Ooh, look out, order change. That's 4, 3, 2, -7. 5 and 10. A lot of times some folks went, why did they flip it around? And they just flip it around real quick without paying attention to the powers. Please make sure you pay attention to the powers, because that's a lot of times your synthetic division oopsies. Okay, I didn't have any breaks. I went 4, 3, 2, 1, and so I'm able to get after this. Now this is nitpicky because of the square root. Okay, so you got to show some stuff. I've got 1 times the square root of 5, which is the square root of 5, but now I got -1 plus the square root of 5. Okay, down here is my answer. Okay, now I got the square root of 5 times -1 the square root of 5, which is 5 minus the square root of 5. Okay, or -5 plus 5, however you want to order it. But now I've got -7 plus 5, which is -2, but that negative square root of 5 stays in. Okay, so I got -2 minus the square root of 5. I'm going to multiply -2 times the square root of 5 and negative square root of 5 times 5. So I got -2 the square root of 5 minus 5. Okay, here. And then I add my 5, so I got -2 the square root of 5 as my result as I add them. Now what's really slick about this, I go in the -5, the square root of 5 times the square root of 5 is 5, times 2 is 10, but take its opposite. I got a -10, which therefore is 0. Okay, so it worked. Just the way they planned it to work, if that ever comes up, there it is. Now, like I said, these happen in pairs. And the thing that's cool about this, once I go through all this work, the second round is much easier. So I'm gonna let you guys do that one. I was going to drink this if you didn't come, you know. He said I could. Now, patience with notation is really what this is. You're still doing the same stuff we've done before. I got a square root to deal with. So we got the 1. I multiply 1 times the negative square root of 5. Well, it's negative square root of 5, and now I add these, and I get negative 1. Hey, that's pretty cool. It comes back to, getting rid of all my issues with the square roots. Now I've got a negative and a negative becomes a positive. Well, again, I get negative 2. Negative and a negative positive, but it's 2 to the square root of 5, I get my 0. Maybe. It's here someplace. Now at this point, I'm not going to have you go all the way through. If you can start factoring something, factor it. Okay? So we were looking at x squared minus 2x minus 2. Okay? So if I've got x squared minus 2x minus 2, I can quickly factor that as x minus, excuse me, somebody went ahead a little bit faster, wrote something down and should not have. I got x minus 2 and x plus 1. Okay, so those are those factors, and I pop them in. I'm able to say f of x is equal to that. Actually, I can lie. I did that there. I didn't think I did that, but okay, good. Let's get rid of that. Questions about what I did to find my factors? Now, keep in mind that square roots, they happen in pairs, okay, when we're working with this. If I just give you one, you can assume the other automatically when we deal with polynomials. Now, my zeros, all over the place. Please notice as I'm finishing, I'm actually pointing out what my zero factors are. I've got my factors, but then my zeros, my values for x to make it 0 has to be there. So make sure you get that in the habit of doing that. Now, if you thought the square root one with the square root of 5 and the square root of negative 5, the negative square root of 5 was nitpicky, check out D. If that's a factor, so is that. Okay? So do that one first. Be patient with yourself. Do the same thing we just did as we go through. And you might have to leave yourself a little bit wider spacing in your values because you're going to have a couple things going on when you do it. Okay, so I dropped the 1 down, multiplied by 1 minus the square root of 2, I got that. Now I combine like terms, I got negative 1 minus the square root of 2. Maybe, okay? Now, I'm going to multiply this, but I'm going to show you a little trick because I see something and I want to show it to you because it'll make multiplying easier. Are you okay that I can do this? And people are like, well, why did you do that, Bloom? I got a difference of 2 squares, okay? If I take this one here and this here, I now know it's 1 minus 2, which is negative 1, and what's the opposite of negative 1? Now 1 minus 2 is my result. The opposite of it is negative 1, positive 1, so it's negative 4 here as my result. Sometimes you can pull a sign out, or maybe even a whole number out, to find a quick factoring of a value using a pattern you already know. So I'm going to do the same thing. I can't do it here. So this next one's going to be negative 4 plus 4 to the square root of 2. And I'm adding 8 to that, so it's 4 plus 4 to the square root of 2. But, again, I see a quick, fast way to multiply in my head. Do you see that I can pull a 4 out of those? And I got 1 plus the square root of 2 times 1 minus the square root of 2. So yet again, I get negative 1. So my value up to the right here is negative 4. I mean, I can multiply that out, but it should be negative 4 coming through. Let's just get rid of that. See if I can get rid of that. Because what I'm trying to tell you is I could just go 4 times 1 minus 2. And that's just going to be a negative 4, and that's 0. Okay? It'll come out the same way. It's just a little easier to multiply when you start seeing those shortcuts. I mean, I can't promise they'll always be there, but if you pay attention to them, it'll help as you're doing your combinations. Now, again, when I'm multiplying these things, they come in pairs because otherwise I wouldn't have that nice leading coefficients, the coefficients of integers, whole numbers working all the way through. Okay, so now I'm going to get these out of the way because they are just there to help me multiply, so they're not getting in the way of the other stuff that's in there. Maybe. There we go. Let's cut that. And now 1 going on, maybe. So I've got 1 drop down. So this is 1 plus the square root of 2. Well, hey, that's 0. And that'll be 0, so that'll be -4. So I got -4 minus 4 the square root of 2. Hey, look, that's 0 as well. Okay, as I finish out. So the first one's nitpicky. The next one is set up to be nice and smooth to even it out, but it's an easier synthetic division than the first one. The first one's always the work one. Okay, remember that's x squared minus 4, which is x minus 2, x plus 2. So I've got my factors as I'm going through, and I'm going to finish out my factor stuff, my factor list here, at least I should be. Because I've got my factor list there, I've got to pull this stuff out of the way. My zeros, of course, should be 2, -2, 1 minus the square root of 2, and 1 plus the square root of 2. As I'm writing out my list of zeros. Remember, I'm showing my factors, and I'm writing out the lists of 0 values for x. Okay. Make sure you're clear and pointing them out both as we go through these. Questions? Doing all right? Yesterday we talked about finding a possible list of rational values that we can use, not the irrational values. Okay, the possible list of rational zeros that we could find. And this next question, I want you to compile the list of rational zeros we can use, but be methodical about it. Makes it easier to find. Looks kind of ridiculous, but here's the thing. After you find the list, and then place this in the calculator. Okay, put that in your calculator and we'll talk about it for a second. Okay, find the list and then put it in your calculator. I'll see if I can get mine in my calculator. After you put it in your calculator, just double check to make sure it's the right function. A lot of times when people put it in, they're like, oh yeah, I put it in right, and we end up graphing something and checking for possible zeros, and it is not even closely resembling the function that we're supposed to work with. Okay. We'll get that over there. Got that in the calculator. But before we start calculating, let's look at our possible list of zeros. Okay. First of all, the factors that we've got to use are from 6 and 8. Okay. So when we're looking at that, we got 1, 2, 3, and 6, 1, 2, 4, and 8 as we get going. And when I set this up, it's plus or minus on these. I should probably have plus or minuses going there, but I will. First of all, I'm going to use 1. I've got 1 divided by 1, 2, 3. So 1, 2, 3, 4, and 6 all come from 1. Doing the division right there. Those are all covered from 1. From 2, keep in mind, 1/2 is new. 2 over 2, I already have in the first list, not going to include it. 3/2 is new. 6 over 2 is 3. I already have it from the first part, the number 1, so I'm not going to include it new or differently. When I divide by 4, I got 1/4, 1/2 again, but we already did that. Okay, and then I got 4 divided by 3/4. That's new. And then 6/4 is really 3/2. I already did that in the green list with 2, so I'm going on to my next number, which is 8. I got 1/8 going, that's new. 2/8, which is the same as a 1/4, we had generated from the 1/4 part of the list. 3/8 is generated new, and then 6/8 is 3/4, and that was in the previous value. So I've got all the possible rational roots. Okay, now these are possible rational roots. The ones that are probable, the ones that are actually used, will be helped out with the calculator. Okay, so if we graph this, it'll come through, hopefully, maybe. Okay, I know I've got one down here at -2. You see that? So -2 is one of my first ones I'm definitely going to be having. So from calc, I got -2. Okay. Also from my calculator, I'm going to check out some others. And they're not so obvious, so I'm going to go in the zoom box and hit enter. And I'm going to move my zoomy over there. Ooh, that's a little far. Sorry, guys. I'm going to go up a little bit so we can see stuff. Okay, so I hit enter. I make my box, maybe. And pull that over. And make my box a little bit bigger. Hit enter. And I can see the other places where it's going to cross the axis. Now, the thing about this I want to make sure you all see when we do this one. If I go for 0, I've got 2 that are funky. This first one should be 0.29. Okay. Might have gone a little bit too far, but that'll still work where it is. So I got my first one. Going to go for my second one, my left bound. Oh, that is my left bound, so we're going to wait a second. There we go, right bound. Maybe sometime this century. So I'm going to work down to my right bound. It's got to be the right of my 0 that I'm finding. Get there. Get my guess. Should be 0.29. Okay, so I got 0.2928. That one is one of my irrational ones. Okay. Right off the bat, I'm thinking I got a plus or minus square root of 2 divided by 2 in my head because that's what it's like 0.70 something. So now I'm going to get that other one. I got a 1 and I got a I know that one's 1, that furthest one's 1 here. I'm going to go for this one and that far one down here. Okay, as we get going. Trace. So my left bound, get over to my right bound. Should be 3/4, I hope. Yep, 3/4. So that's another one I've got going for myself. I got 1, and I got 1 more I'm going to go after. My 0. I'm not going to go after the obvious 1. Go after this thing that's out here that looks like it's like, well, maybe 1.7 or something like that. So I got my left bound. I can hit that left bound wherever I want, so long as my right bound is on the other side. My left bound's got to be on one side of it. My right bound's got to be on the other side of it. Maybe, if it lets me. And we hit that. And we got 1.729, they're saying it's close to, but 1.707. So that was my other one, 1.707. I wrote it on my stuff that I got going here. So I got that, Those are irrational. I got 3/4 and -2, those are my rationals. And those are all from my calculator. Okay, so it's given me a really great start, and I decided to start at 1 just because, and I'm filling those in. So let's go and get 1, -2, and 3/4. Okay, so you guys got those. Please do those, okay, and use those. Remember, we're going to use our rational values, our rational zeros, to whittle out the factors down to the irrational ones, and then we can deal with the irrational factors, the last two. Okay? Go ahead and get the rational ones completed. Remember, we did the list because we were asked to do that in the problem. That list helps us find the rational possibilities. Our calculator will finalize those from possibilities to actual factors.
Have a good afternoon,
I suppose we should actually do this in the right order. I had -6 times 1. It's -6, so I get myself a -28 here, times 1 again. And it should give me 29. And I multiply by 29, and I get myself a -6, and I multiply and I get a 0. So then I go after -2. At this point, I could choose to do either one. I decided to do this order because that's what I felt like at the time today. So 8 times -2 is -16. So I got -22. Multiply, I got 44. I got 16. Multiplying it, I get a 32. And I get a -3. Multiply again, I get a 6. And I got my 0. And 3/4, I got 3/4 of 8 to 6. Okay, so I get that up there. And I get 16. It's my answer. 3/4 of that is -12. And I get a 4. 3/4 of that is 3. And I get a 0. And I'm able to get to my next step. I'll let that sit right there for a second. Now what I want you to do is give yourself an opportunity to try completing the square. Okay? Give yourself an opportunity to try completing the square step. Before we get there, let's whittle out a little bit. Now I got that 3/4. So I'm at this point right now, and people are like, where did the 3/4 go? And I want to show you what's going on. I got x minus 1, and I'm just rewriting a couple of these because they're exact, x plus 2. But here I had x minus 0.75. Okay, and then I had 8 And well, I've got 8x squared minus 16x plus 4. Where did the 4 go? I took a 4 out. And I have that 2x squared minus 8x plus 2. That 4 went over here to help me with 4x minus 3. So I could make sure I had that function there as, excuse me, that's me. Okay, so we have this coming through, and now I just do the completing the square with that. Okay, so separately, I've got 2x squared minus 4x plus 1 equals 0 for completing the square. My first thing in completing the square, the leading coefficient needs to be 1. Okay, so I divide that out, and I have x squared minus 2x plus 1/2 equals 0. I'm going to get that 1/2 to the other side. Okay. Remember, we divided that out. We got to come back with that. So now I've got x squared minus 2x plus something equals negative 1/2. Okay. So what's the something I'm going to add? Half of b squared. So half of b is 1 squared. I know it's negative 1, but when I square it, it doesn't matter what the sign is. Okay, so I'm going to add 1 to this side, hopefully. Now I've got x minus 1, that's my perfect square I just made, equals 1/2. Doing okay? Take the square root. Now, this is plus or minus the square root of 1/2. And I'm going to rationalize, I can take the square root of top, which is 1, but I got to rationalize it because I can't have the square root of 2 on the bottom. So I'm going to hang on to this for a second. This can be plus or minus the square root of 2 over 2 because I'm doing this over here. Okay, to make it all nice. Finals, plus or minus the square root of 2 over 2. Okay, we okay with the steps? Are there any questions about that completing the square? Remember, I'm just completing the square to find the zeros for that part of the value because the other ones are easy to find. My zeros should be zeros for x are 1, negative 2. We got 3/4 and 1 plus the square root of 2 over 2 and 1 minus the square root of 2 over 2. Bless you. We okay with those? And how to step through them? Now, there's a couple ways to do this next challenge problem that we've got here, this very last thing. But I want to make sure you recall remainder theorem. What does remainder theorem let me do? You recall using it? We did it day 1. We did it Friday. Remainder theorem, if you take your value k and put it in for x in your polynomial, the result is the remainder that that value will have when you divide. Okay? When I'm looking at a factor theorem that's an extension remainder, and my result is 0, that means that k you plugged in was an actual factor. The reason why I'm saying that is this problem can be done doing synthetic division, or I would prefer you think about remainder theorem. So if I use remainder theorem, k is negative 1, right? You okay with this? I'm going to plug in my value of -1 in for x. Okay, now when I have a remainder theorem and it is actually a factor, what is the remainder? When I'm thinking about remainder theorem, it's an actual factor. What's the value that this should come out to be if it's an actual factor? 0. Okay, does that make sense? So my p of -1 should be 0. Okay, so I've got -1 to the 4th power, 3. K to the times -1 to the 2nd power, k. And +2 +1. So what's my value of k? Solve. -6 should be k. So ideally, I should have, if I check, 3, 0, and I'm saying it's -6, -2, and 1, I should be able to show that this works by doing synthetic division all the way through. Is my proof that the answer works. Okay? What I'd like you to do is apply that same idea to problem B. Same idea to problem B. We're doing okay. Same method. If we want, we can check it out. The k is 11, -11/6. Okay, but I have overstayed my welcome, I am sure. Okay, I hope this is going well. We got today's assignment. It's up on the board. I will copy it into this, make sure it's there. I got 2-4, day 3, page 205, numbers 49, 55, odd, 57 to 61, and 67.